Hello students, today we are in lecture number 20. Of chapter 2, Electrostat. This is the second chapter of NCERT, my dear student. I am B.S. Pandey. Student, today in this lecture, we will start with the relation between electric field and potential. Okay, it is the mathematical relation between field and potential. As we have done with the relation between force and potential energy, in the same way we are going to establish here the mathematical relation between field and potential. My dear students, I have established a relation between work and change in potential energy. You might remember it was W is equals to minus delta U, and this W is nothing but the work done. So we can write this work done as F dot dr, and this delta, which is the mathematical operator, we can use with the proper limit, this one, to give you the d, that is the derivative tool. This can be also written as the minus du. Now student, as we know that if any charge placed in presence of electric field, it experiences a force. If we are talking about the charge, it is Q times E dot dr, and the same charge measures the potential energy U with the potential V. So we can write minus d Q times V. This is the potential. This potential will change to change the energy. Remember, here the charge will not change since charge is constant, and this Q will cancel out. Finally, we'll have this E is equals to minus dV over dr, a very simple relation between electric field and potential. This is also called potential gradient. Potential gradient, my dear student. So you have to remember this equation as E is equals to minus dV by dr. Since this E is vector quantity, as you correlate the force with energy, you can also write this E in vector form as minus dV over dx with I cap plus dV over dy j cap and dV over dz k cap. Remember students, while you are talking about the very small quantity, you have to take the partial differentiation, and that tool we have discussed in detail. But here we are getting very important formula from this E times this formula. This is the very important formula. You can represent this formula as this one also. It is E dot dr, this one E dot dr, both are the vector quantity, is equals to minus dV, and you know that dot product will give you the scalar quantity. This potential is scalar quantity, and this formula will help us to find or to solve the number of questions. Remember student, I can give you the number of questions to solve on the basis of this equation. I'll give you the potential, which is the function of space, and you will differentiate, that is the partial differentiation, and get the electric field. but that would be the wastage of time because you have solved number of question on the basis of that one only. Okay, my dear student. So moving forward to solve few important question. Student, if you will write this equation to just generalize, you can write in this way also, as we know that in mathematics we used to write, if this is E dot dr, E dot dr integrating, it is minus dv. So you are giving the limits, initial limit to the final. Okay, here also initial to final. Okay, my dear student, or you are writing this way, E dot dr initial to final, limit I am putting, minus, and thus dv can be written the v, and v final minus v initial, minus v initial, and this minus can be compensated at the v initial minus v final. Finally, you should remember this formula, that is the very helpful, v initial minus v final. Suppose if initial point is a and the final point is b, then you can write E dot dr, initial was a, so from a to b. But the important relation would be that you have to remember v initial v final is equals to E dot dr. Okay, or from initial to final, or the va minus vb is equals to E dot dr from a to b. Thus dr is position vector. Remember, my dear student, this is the position vector. You have solved already to find this position vector. Okay, in very short, I'm recalling you, if this is the coordinate and this is the point P, X, Y, okay, and this is the O. If you're writing the position vector OP, my dear students, you have to write directly is X minus, here the coordinate is 0, 0, X minus 0, that is the XI cap, plus Y minus 0, that is the YJ cap. Okay, student, again I'm recalling you another. If this coordinate is 2, 3, this coordinate is, this is O and this is P, this coordinate is 5 and 2, then you have to write the OP, position vector OP, and that will be considered the dr. This will give you the dr, and this OP you have to subtract from P to O, that is the 5 minus x1, 5 minus 2, it is the 3i, plus 2 minus 3, it is the minus j cap. Okay, student, so this was, I was recalling you, this is the position vector. Okay, and this way you will get the number of question to solve. Now the very simple example I'm taking, the very simple example. Suppose this is electric field, and in this electric field you are getting 2 points A and B. This is the uniform electric field. Suppose it is EI. Okay, from here to here, this is the point A and B, my dear student. The coordinate you are given 3, 0, and of course this will be the, since on x-axis we are changing, suppose it is 6, and y not going to be changed, it is 0, and you have to find VAB. The question, find first one VAB, you have to find, and the second question, at which point potential is maximum, potential is maximum. Okay, my dear students, remember, while I was teaching you electric field lines, I told that time electric field lines always move from higher potential to lower potential. If this field line is moving in this direction, it means this point to this point, it means A should be at high potential and B should be at low potential. Okay, from here, from this theory, we'll get the answer, so that, and we'll verify, yes, point A is at high electric potential. Now, so look at it carefully, my dear student. What is the formula actually? the formula should be recall again so that it remember. EDR from A to B, it is VAB. Okay, this is the formula. Now we are going to apply over here. VAB E dot dr. What is EI dot dr? So dr is the position vector. Dr is the position vector, and that position vector gives you the 6 minus 3. It is 3I cap plus j. 0 minus 0. So the 0. I am not having any component on j. So EI dot I1, and it is 3E. Now this VAB can written as VA minus VB, okay, and it is 3E. Now my dear student, you can see this VA is 3E plus VB. So which one is greater? Actually, in first question it was asked to find VAB. So this is the answer. And in second question we have to find at which point potential is maximum. We are getting potential at A is 3E more than VB. It means VA is greater. Okay, VA is greater than VB, and it is proved that electric field has moved from higher potential to lower potential. Why this B is at lower potential? It proves that. Okay, my dear student. Another question I'm giving you. If you can solve, try to solve this question by yourself. And I'm giving you this question. It has been asked in board examination. Okay, in CBSE it was asked. This is the field. Okay, again it is I. Suppose this one. 3 points A, B, C. Alright, I'm giving you the coordinate. Suppose it is okay, origin 0 0, and the point B is, suppose it is 0 x 0, okay, 0 3, and point C, suppose since y x is changing and y is also changing, suppose it is okay 7 3. You have to find the question. First VAB, second VAC, third VBC. Which point is at high potential? Okay, so this is the question you have to find. If you can solve, try to solve by yourself. Pause the video and try to solve this question. Okay, my dear students, now look at here over the solution. As we know that E dot dr is VAB. Okay, that is the AB, it means the initial and final. Okay, let me write over the 1 2. So the first we are going to find out between A and B. So we can write here the AB, VAB. So the VA minus VB, it is for this 2 point. Electric field is not, electric field is uniform for each point, so it is EI only dot dr. Okay, so the dr final point is this one. So the 0 minus 0, I is gone. Now 3 minus 0, it will be 3, but j cap. Okay, and I dot j is 0. Here the VA minus VB, that is the VAB, how much? 0. Potential, this is called the potential difference. In standard 10th you have studied already the difference between difference of potential between 2 points is called the potential difference. So it is the potential difference is 0, and potential difference 0, it means that point A and B at the same potential, VA equals to VB, and this line actually is called equipotential. equipotential, my dear student. We study in detail about this equipotential surface. Suppose if you are if you are having the number of points, the electric field is moving from this direction to this direction. Okay, electric field is moving from this direction to this direction, and you have this is the plane. Okay, in this plane, the number of point you will study, each point will be at the same potential. Why? Because electric field is moving in this direction, and all the points are at the same plane, in the same plane of this perpendicular electric field line. It means all the points will be at the same potential, and then this plane will be considered the equipotential plane, or the surface will be considered the equipotential surface, and the same surface we will study later on. Okay, might be in the next lecture or in this lecture only. So this is now the next question, my dear student. This was the first question. Now the second question, VAC. I hope you can solve. It would be better if you solve by yourself. Okay, so I'm leaving this one. You can solve by yourself. Now the next concept, my dear students, if I draw a line perpendicular to the uniform electric field, okay, this is the uniform electric field. If I draw a line perpendicular, it is perpendicular at both the point. It means at each point on this line, potential will be same. Am I correct? Yes, potential will be same at each point. But if I'll tilt, this is the uniform electric field. If I tilt this line, whether the potential at each point on this line will be same. So answer is no. Potential will change. Potential will change. It means this is the equipotential line or the equipotential surface, but this is not the equipotential line or equipotential surface. And it proves that the equipotential surface, if it is the equipotential surface, then equipotential surface always perpendicular. Okay, always perpendicular to the field lines. If you want to find out the equipotential line or surface, you have to draw the perpendicular line. Okay, this concept we will use later on. Okay, we are starting actually the equipotential surface. Write down the topic, equipotential surface. Equipotential surface. Remember student, again I'm telling you, as I told you number times, that I'm not solving here too much questions for your practice because we don't have sufficient time. My lecture would be of 30 minutes hardly. So you must do practice over my given assignments as I have been given in group. Those students require my assignment, they can contact me. You can comment in last of the video. Okay, otherwise you can ask your friend to get the assignment. That assignment only will give you the concept how much idea you have collected from this lecture class. Okay, my dear student. Now this equipotential surface, student, kindly write down the definition of equipotential surface. Remember one thing, the equipotential surface is nothing but the common surface. Okay, common surface or plane. It is the common surface or plane having same potential. Okay, having same potential. It is the common surface or plane having same potential. We are talking about the electric potential. A very simple example if I'll give you, earth is equipotential surface for us. Okay, for us this, all right, earth is equipotential surface for us. Suppose if I'm telling you to draw equipotential surface, this is the charge, a charge. You have to draw the equipotential surface. Which type of equipotential surface you will draw actually? So first you have to draw, remember, to draw the equipotential surface, first you have to draw field lines. Remember, this is the very important. First you have to draw electric field lines. Kindly write in your notebook, in note, draw electric field lines. This is the first point, which is very important. And this is the isolated charge, one charge, okay, monocharge. It means to draw the electric field lines, what we have to draw actually, perpendicular everywhere. If you find the potential at this point from the charge, if it is at 1 meter, give a locus, a point at 1 meter, another at 1 meter, another one at the same distance, because we know that formula for potential V, it is kq by r. So at r distance you will get the equal potential. Now make the dotted line. So what is the concept to draw the equipotential surface? And this is the equipotential surface. It is the equipotential surface. Okay, my dear students. It means if it is the point A, this is the point B, this is the point C. It means VA, it is equals to VB, it is equals to VC, and this is called the equipotential surface. What you have to be bear in your mind, that is, first you have to draw the perpendicular dotted line, and that line will give you the equipotential surface. Actually, I'm considering here the three-dimensional picture. If we are considering the three-dimensional picture, then it looks like about a point charge. Around the point charge, it looks like a sphere, and this is the equipotential surface. Okay, my dear student, this is the story of one charge. If it is the positive, if it will be the negative, the same potential surface you will get. Now next one, remember, if VA and VB both are equal, it means VAB will be how much? 0. So the potential difference between any 2 points on the equipotential surface must be 0. This will be the important point. All the point I'm telling you, student, you have to make as your note. Okay, as your notes, you have to write in your note copy. The next point, my dear students, if I ask you some important shape of equipotential surface, okay, I'm making the heading. Write down shape of equipotential surface. I'm giving you some conditions as I given you this condition. This is the uniform field, this one. Now you have to draw equipotential surface, my dear student. What will be the nature of equipotential surface over here? Of course, earlier we studied the equipotential surface must be perpendicular. So this is the nature. Okay, this is the equipotential surface, my dear student. Remember, this is the two-dimensional picture. This is the plane, actually this one, or this one. So over this plane, at each point you will get the potential same. If you wish to find out potential at this point, at this point, at this point, at this point, okay, suppose it is A, B, C and D. So the VA equals to VB and VC equals to VD. But remember, VA not equals to VC. Why? As you are moving forward, this is the electric field. As you are moving forward in the direction of electric field, the potential decreases since electric field lines move from high potential to low potential, and it is quite clear VA is greater than VC. VA is greater than VC. So number of questions is being prepared over here. So this is the shape of equipotential surface. If the electric field is parallel. Okay, the next step I'm asking you, kindly move back and draw the shape of equipotential surface. Now the next one, if this is dipole, okay, dipole, this is minus charge, this is plus charge, you have to draw the equipotential surface. First, what I told you to draw the electric field lines. So this is the electric field lines I'm drawing. You can draw much better than myself. I'm not good in drawing. So this is the positive charge, and positive charge leave the electric field lines. It will originate and collected by negative charge. I hope, my dear students, you remember. Of course you should remember, this is not the very tough. Now we have to draw the equipotential surface. Okay, so I'm going to draw here the equipotential surface. Equipotential surface, we know that the equipotential surface should be perpendicular. This one. Okay, now the next equipotential surface, this is the equipotential surface. Remember, it is not necessary that the potential at both the point will be same, but the potential at each point over this will be same actually. Now the next one, as you will draw, it will be turned, but you can see here the line is curved, so it will be a little bit flat. You can see the change in shape. Here it will be round, but it will be like flat. As you will move much closer, you will get another flat shape and another much flat shape. But the important thing, and you can draw here a very flat, but this is all other equipotential surface. And remember, two equipotential surface never intersect each other, never intersect. Now you can go back and try to remember as I draw the uniform field lines. If it is the perpendicular to the electric field lines, so it is not possible, because one and the another field lines which are parallel never intersect. To intersect, one should be slant, and if it will be slant, then the potential at each point will be not same. So two equipotential surface never intersect each other. But what happens if we draw the equipotential surface in case of the two charges of the same nature? Very good. Okay, so the two charges of the same nature, look at here, if it is plus and this is also plus. Okay, my dear student, first you have to draw the field lines. This is the field lines. Now it should be never intersect, my dear student. You can make much better diagram as I told you, and you should make much better than me. Okay, now try to draw the equipotential surface. Look at here, I am moving equipotential surface this side, it is moving round, no doubt, round. Very good. Okay, round. This is the one equipotential surface, but over here again round. But we move, as we move closer, remember this line is not going to this one, so as the potential surface will move here, it will go down, but over here it will go up. So whenever the two electric equipotential surface comes near, it never intersect, but it merges in each other. Okay, it merges in each other and it will looks like this one. Two equipotential surface when comes near, it merge each other. The two, if I'll make like this one, so it should not be there. So it merges to each other but never intersect. Okay, it merges to each other so that you can get the electric field lines everywhere perpendicular. Over here also it is perpendicular, here also it is perpendicular, and it is perpendicular. So equipotential surface always perpendicular to the electric field lines, student. So those are the important points. Remember, electric field perpendicular to equipotential surface never intersect each other. These are the important point of the equipotential surface, and many more you can get in NCERT. So this is all about the 2D lecture, my dear students. Thank you very much.